These are quadratic equations, and just to get an idea of what it looks like, I have some points here. Let's fill them in, hit pause and fill them in, and we get these points. If you notice they're symmetric, we have a 0, and then it's 1, 1, 4, 4, 9, 9. So when we graph it, we're going to get a certain shape. So plot them, and then connect the dots. So we get this shape. This shape is called a parabola. And what we're going to be doing is graphing a bunch of these parabolas. But there's a nice pattern between these equations that we have and the parabolas that they form. So that's what we're going to be looking at. Let's start with just putting a number in front of x squared. So I'm going to graph them for you. So after plugging in our x values, you notice the square is just going to turn everything positive. So this is really 2, 0, 2. And this one is 3, 0, 3. And this one's 1/2, 0, 1/2. So do you see a pattern? Whenever you plug in 1, it's giving you just that number that is in front. So when we graph it, you have 0, 0. Pick a different color. 0, 0. Negative 1, 2. And then 1, 2. And that will give us our graph. And then here it's negative 1, 3. 0, 0, and 3. And then here it's 1/2, 0, and 1/2. So when we graph it, it looks like that. So, and that one looks like that. And that one looks like that. So if you notice, the larger the number in front, the narrower the graph is getting. And the smaller the number, the more wider the graph is getting. These are getting stretched, and these are getting kind of squished. But the nice thing is you really don't have to plug in points. If you see a 2, the first point is up 2 over 1, up 2 over 1. If you see a 3, the first point from the 0, 0 is up 3 over 1, up 3 over 1, and then same, it's 1/2 over 1, up 1/2 over 1. So it's already clean. We don't have to do anything. So that's the first thing, the number in front. Now what would happen if we add or subtract to each one? Well, if we subtract 3, it's doing something. We add 2, it did something, and we put plus 1. So hit pause, take a look at them, and see if you can figure out what's going on. Exactly. Its opposite of this number is how it's going to move in the x direction. So it's going to have a horizontal shift of 3 units, a horizontal shift of -2, and a horizontal shift of -1. So if we had x minus 5 squared, it would go to the right 5 units. It would take that whole x squared and move it over. And you notice it's also the axis of symmetry. This is x equals -1. This is x equals -2. And this is x equals 3. That's where everything is symmetric about. So that number right there is giving you the axis of symmetry, the opposite. All right, what if we add numbers or subtract them to it? So take a look at these and see if you can figure out what's going on. Exactly, if you add 2, it goes up 2. If you subtract 3, it brings the whole thing down 3. And if you add 1, it brings everything up 1. Because that's what you're doing. You're taking every point from the original x squared graph that we have up here, and you're adding 2 to each of them. So if you add 2 to 0, you get 2. You add 2 to 1, you get 3. You add 2 to 4, you get 6, and so on. And then same thing here is you're subtracting 3 from every point, and this one you're adding 1. And that's everything that you need. So the number in front tells you how much to go up and over by 1 unit. Whatever you add or subtract to the x will move it in the x direction. And whatever you subtract or add to the entire function will move it up and down. So we have these 3 letters, A, H, and K. A, H, and K. And what A does is this is our up A over 1. It's a scalar. And H is our horizontal shift. So it moves it in this direction or that direction. That looks horrible. Let's try that again. Moves it in this direction or that direction. And then K is our vertical shift. It moves it up and down. And then if you're moving it up, K, and left and right h, what that is giving you is this special little thing which is called the vertex. That's this point right here. That's our vertex. Vertex, vertex. So, vertex. So that's where we focus everything at. From the vertex, if it has a -2, a +2, and then it moves it to the left 2. So our vertex is now at 2, 0. Okay? So for this one, it really is this form. There is no h and there is no k. So if there's no h and no k, our vertex is at 0, 0. And that's where you want to start. You want to label the vertex. And then it's up 5 over 1, up 5 over 1. That's all you do. This is our A. So you place its vertex, which there's no h and k, so it's 0, 0. And then our A is 5, which means we go up A over 1, just like we did here. Up 2 over 1, up 3 over 1, up a half over 1. And then we can graph. They're this quick. So let's look at another one. So our vertex here, there's nothing being added or subtracted to the x, so there's no h. But we do have a k, which is 2. So it's 0, 2. That's our vertex. And then our A here is 1. So we go up 1 over 1. Do that in green. Up 1 over 1, up 1 over 1. And then we can put a dot, and there's our quadratic. That's it. No points to plot, nothing. Okay, let's do 2 more. Let's do a couple more. Alright, so this one, nothing's being added, so we get a 0. But we do have a -3. So we go down 3, put a dot. And that's our A. It's 3, so we go up 3 over 1, up 3 over 1, and graph. So 5, you go up 5 over 1, 3, you go up 3 over 1. Alright. This is our last one. I'm going to pick this one just to show you it. So for our vertex, we have a -2, so we do a 2. It's opposite for this one. And then we have a +1, so it's a 1. So we put a dot at 2, 1. That's it. That's our vertex right there. 2, 1. And then we look in front of whatever's being squared, and there's a 1 there. So if it was a 2, we'd go up 2 over 1. If it was a 5, we'd go up 5 over 1. 3, up 3 over 1. If it was a half, we'd put up half of 1, but it's a 1. So we go up 1 over 1, up 1 over 1. And that's it. So give these a shot. See if you can graph the rest of them for me. And then they will appear, and I will go over them. And pause and try it. And here are all the answers. So this one is nothing, there's no k. So it's 2, 0. And then there's a 1, so it's up 1 over 1. So we're at 2, 0, up 1 over 1. This one is -3, 0, right here. And then it's up 2 over 1, up 2 over 1, because of the 2. We already did that one. Alright, they're all 0, 0 in this row, because there's no h's, no k's. Nothing's being added or subtracted to them. But we have a -1 now. So instead of going up 1, we go down 1 over 1, down 1 over 1. And then this would be down a half over 1. And this would be down 3 over 1. And that's it. So putting it all together, this one is not graphed correctly. Let's try that again. It's 2, 1. And then from that number 2, it's up 2 over 1, up 2 over 1. And there it is. So it's 2, 1. And then up 2 over 1, up 2 over 1. And this is -1, 0. So it's 1, 0. And then down 2 over 1, down 2 over 1. And then it's -3, -1. So -3, -1. And then down 1, down 1. And that's it. So there's only 3 things to look at when you're graphing these quadratics. The number in front tells you how much to go up and over. The number being added or subtracted to the x tells you your horizontal shift. It's always the opposite of that number. And then whatever's being added here is your vertical shift. And that one's exactly the same as whatever it is. And putting them all together, this will allow you to find your vertex off your h and your k. So it's h and k. You can plot the vertex and then go up and over. And that's it. And if you're going to have to label an axis of symmetry, it's always the x. That would be your axis of symmetry. All right, thank you.